talking about atomic structure, fundamental particle of an atom. So that is of the atomic structure. Then this is the nucleus. In the nucleus, we have proton and neutron, and the electron involved around it. So there are three fundamental particles here. We have the proton, we have the neutron, and we have the what? The electron. The proton is positively charged, the neutron is neutral, while the electron is negatively charged. The proton and the neutron can be found. The proton and the neutron can be found in the nucleus, while the electron can be found in so this you have number one proton, number two you have the electron, neutron, then the summary. You have this is the proton, neutron, electron, and the location. Where can you find it? The location is on the nucleus, shell or orbital. Charge. Positively charged. One atomic mass unit. One atomic mass unit. 1/1 mass unit. AM means atomic mass unit. That's AM, atomic mass unit. So, in an element, you can find these three particles. So, let's use this symbol to represent this symbol of element, And this is A, and let's call this one S. This is the mass number. This is the mass number. The mass number. This is the atomic number. Atomic number and mass number. Atomic number is the same thing as proton number, electron, if electrically neutral. Then the mass number is proton plus neutron. Proton plus neutron. The proton plus the neutron. So the atomic number is the same thing as the number of proton in the nucleus. Atomic number is equal to what? Then the neutron is what? The mass number minus proton. Complete and copy and complete the table below. name of elements, atomic number, number of proton, number of electron, number of neutron, mass number. Let's say this is, let's put this one. Now, let's say carbon. The atomic number is 6. The proton number also be 6. Proton number also be 6. Then the mass number 12. 12 minus 6. Then nitrogen. Now this one, the atomic number is same thing as proton number. Same thing as the neutron number. So 14. Then the last one, calcium. This one is 20 dash 20 dash. So the same thing, 20 here, 20 here. 20 plus 20, 40. So what about if it's electrically neutral? If there is neutral. So you go like this. Element, atomic number, mass number, proton number, electron number, neutron number. Now looking at this question now, I want to analyze this question on the board. How do you solve this? This is sodium atom. The next one is sodium ions. Third one is chlorine ions. And the last one is chlorine ions. So the number of protons, this is proton here. This is proton here. And also has the same thing as atomic number. So the atomic number is 11. The mass number, this is mass number, 23. Then the proton number and the atomic number are the same thing. Then if it's neutral, if there is no charge here, you have 11. Then the neutron, 23 minus 11, that is 12. Now look at this one, the same thing. Atomic number is 11. The mass number 23. The proton number is the same thing as what? This number that is here. Then the electron, because he has a positively charge, that means he has donated 1 instead of 10. It will have donated 1 instead of 11. Will come 10. And this one come normally 23 minus 11, 12. Now, this one, the atomic number is 17, the mass number 35, the proton number 17, the electron number 17, then the neutron number is 35 minus 17, that is 18. But in terms of this now, is chlorine, it has what? A negatively charged. Still 17, 35, still 17. But the electron, you have accepted one electron, that's why it becomes negatively charged. So when you accept a negatively charge, it become 18, and the neutron is still what? 18. So this one will now lead us to isotopy. Isotopy. What is isotopy? Isotopy is a phenomenon whereby elements have the same atomic number but different mass number. Elements have the same atomic number but different mass number. Isotopy. Isotopy. So this is a phenomenon. This is what? A phenomenon whereby an element is having the same atomic number, but different mass, number, or this is a phenomenon, whereby an element is having the same proton number but different neutron number. So it's a phenomenon whereby elements have. So what are the examples of elements that exhibit e.g. hydrogen. Hydrogen is one of the elements that exhibits. We have the hydrogen H11, hydrogen 12, hydrogen 13. Hydrogen is called protium. This is called deuterium and tritium. So we have protium, tritium, and tritium. We also have oxygen 2. Oxygen 2 exhibits isotopy. Oxygen. We have oxygen. Others are oxygen. Oxygen is 16, O8, and then 18. We also have carbon. We have chlorine 2. We have carbon 12, carbon 14, 6, and this carbon 14 is more used for dating agents. Then we have chlorine. Chlorine is 60, 17, 35, and 60, 37, 17. So you see that they have atomic number common, but the mass number are different. Let's look at this question together. Let's solve this question together. Let's go to this question together. Let's go to the question. Example. Example 1. Consider two atoms represented as Q. Now, this formula 1 and 2. Now, A, what is the relationship? What is the relationship between the atom above? You can also say B, deduce the number of photons of each atom. See, what is the mass? What is the number of neutrons? What is the number of electrons of each atom? Deduce the number of neutrons of each atom. So look at the question now. They say we should consider the two atoms represented as this is the element S, the mass number is P, and the atomic number is Q. Second one is M, mass number M, and not Q. So what is the relationship? The relationship that you can see here is that they exhibit isotopy. The relationship is what? Isotopy. That is the relationship they exhibit. Because of what? They have the same atomic number, but different mass number. Same atomic number, different mass number. Same atomic number, different. Then what is the number of proton? The number of proton in Roman figure 1. The number of proton here is P, and in Roman figure 2, second element is also P. What is the number of electrons? Because it's electrically neutral, the number of electrons is the same thing. No, this one is Q, sorry, QQ. While this one, the electron here is Q and what? Q. It's Q. This is the proton, atomic, or electron. Proton, atomic. Then this, the last one here, this number of neutrons. Number of neutrons here is, for the Roman figure 1, is P minus Q. Then for the second one, Roman figure 2, will be equal to M minus Q. That is the number of proton, neutron, and the electron. So that's that on that. Then how do we calculate the calculation of relative atomic mass and percentage abundance of isotope? How do we calculate that? So the answer for the first one, A is isotopy. B, number of proton. In the first one, Q, and hemagglutinin 2 is also Q. C electron, I is equal to Q, then this one also what? Q. Then the neutron, I is equal to P minus Q, and second one is also equal to what? M minus Q. So we are moving to calculation. We are moving to the calculation. Calculation of relative atomic mass from percentage abundance of isotopes. Now we are given, let's use this example. Example 1. You say that the two isotopes of chlorine and their percentage abundance are 75% for 3517 chlorine and 25% for 37 17 chlorine. Calculate the relative atomic number, atomic mass of chlorine. Now this is what we do. Solution. We are given this 75% of 35 then, and then 25% of 3717. So this is what you do. 75 over 100 times the mass number. Add it together with 25% over 100 times 37 over 1. What are we going to get from there? So the answer there is 37 times 5. And this one is 5 here, 7, 5 here, 20, 5 here, 15, 5 here, 4. So we have 105 over 4 plus 37 over 4. Add them together. 105 plus 37 over 4. That is 142 over 4. That is 35.5. That is 35.5. Look at it very well. That is 35.5. So another example. It can also come in form of fraction. Another example. Example 2. If the isotopes of chlorine are 75% and 25% the relative atomic mass of chlorine is 35.5. Find the value of S. Find the value of S. Now, solution. Just like the way I saw the other time. So this one, 75% of S 17Cl anode, 25% to give us 35.5. So just do like this. 75 over 100 times S over 1 plus 25 over 100 times S over 1 to give us 35.5. So we can 3S over 4 plus 1, but because we are solving it like Jambite, we don't want to use calculator. 35.5. So finding the LCM, 3S plus 37 over 4 equal to 35.5. Then cross multiply. That's 3S plus 37 is equal to 35.5 times 4. That's 142. 3S plus 37 is equal to 142. 3S equal to 142 minus 37. That is 3S is equal to 105. Over S equal to 105 divided by 3, which is equal to 35. Q is equal to what? 35. So stop for here today. Next class we are going to talk about atomic configuration. Thank you. Thank you so much. Any question?